Before we get everything over to Fusion, I thought actually it might be a good point to talk about why do we model something in Blender and not do everything in Fusion. And this is actually a good example for why a sub-D polygon-based modeling approach has a lot of benefits. So first, this is a very fast way of modeling something organic and complex like this. You saw with all the orientation tools, we have perfect control of positioning our points where needed. Via the modifiers, we can simulate actually a lot of Fusion-like modeling features. We can't necessarily do everything. So I can't round this edge. I can't also right now trim these two surfaces. That's something, again, we will do in Fusion. But to create the main broom and the dustpan is super fast. Now, let me go into edit mode for a second, and I will turn this one on and take a look at this. There, 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 or here are just circular cross sections, profiles. And then there, and there, there, here, there are rails. So let me go to Fusion. So there's the design. Now, this is all done purely in Fusion without the help of Blender. It works, but there's actually quite more labor intensive. This is the amount of construction planes I need. And that's the amount of sketches I need to control all the surfaces. So the question with such an organic shape then everybody can ask is, do you want to start right inside an AdCAD application and use the traditional sketch plane, sketch surfacing approach? Which, as you can see, is possible, but it's also slow and labor intensive. Or do we use a more contemporary approach to creating such organic shapes via simply sub-D surface modeling? Because the nice thing is, all this we're going to send over to Fusion anyway, and then do all the details in the application there. So with all that said, let's get all the stuff over. So the whole I would like to export. So this one, the dustpan detail, and then also the broom and the dustpan. Select all those, file, export, selection only, Y up, Z up, Y forward. There's my part to export. Let's go to Fusion. Let's make a new design. Bring in the mesh. There it is. Meters, okay. New create form, convert this whole thing into T-splines. Very good. We can nearly continue. Here we have to crease some edges now, like these edges, they have to be creased. Same here. To select these edges. And while we have, again, T-splines built into Blender, Fusion, it does not have the same modeling depth than actually a dedicated polygon modeler like Blender, Cinema 4D, Maya, or such. And the main reason, again, why I use Blender is simply it has more modeling tools. It works well with Fusion and it's free. Okay, so this looks actually pretty good. Yeah. So at this point, let's click Finish Form, and we can continue creating our details. But see this stuff here? This is kind of terrible. So it's very faceted. It's not necessarily bad, but my feeling is this can lead to a certain amount of issues. So I will try to fix this actually. So I will go back and delete all this and that. Go back to here. Shift H, I only want to see the dustpan and turn this off and this off. I go from the underside. Very good. AA, press K, and then I see it snaps to this point, and I move a line to there, press enter, and I added an edge. Press K, we do the same from there to there. Press enter. Now K. I want to find the midpoint. Hold Control. You see it snaps to the midpoint, to the midpoint, to the midpoint. Press enter. Very good. And we can select this point, switch to normal, slide it down. Actually, normal and bottom is actually the same orientation. Yeah. There. I want to have 4 points, 4 points, so it's quad faces. Very good. And do detail there, AA. I'll just export that whole stuff again. At this early stage, if you see such a mistake, that's the reason why I built this in on purpose. It's easy to simply export everything one more time than trying to fix stuff. So you bye-bye, insert, there we are. Okay, create form there, convert you, okay. And then we know decrease, double click. Unfortunately there's no double click, so I have to click on all these edges by hand. Very good. Nice. So, and then you can see here we have a much nicer face layout compared to what we saw before. If we now click Finish Form, we maintain having this actually. Super. Okay, so to bring this part of the video to an end, we are facing actually one problem. This whole thing here is, no, we do not face any problem. I shouldn't have said that earlier. We're actually good. We have individual objects. Very nice. Okay, so there's no cleanup that's necessary. So after this import, let's try to quickly create all the surface interaction or relationships the way I want. Go to patch mode. We go to trim, select this broom, no, dustpan, and then we click on this part and cut it. You see it's removed. Then one more time, trim. Now we select this and click on that surface of the dustpan, click OK. There, it's cut away. Pretty cool. Awesome, very nice. Then this and this we want to stitch together, so it's one object. Very good. Let's create a thickness. We know by the measurement that's 4 millimeters. So -4. No, wait, that wasn't 4. It wasn't it 3? Yeah, it was 3 millimeters. 3 millimeters. Very good. Okay, and then this body we can remove. Very nice. And is there anything else we can try to fix? This is not necessarily really looking great because of all these faces there. I could go into T-splines and then select this face, press delete. So we remove it, finish form. And Then in patch mode, click this edge, patch, go to stitch and stitch this together. So it's a nice flat surface. That cleaned it up a little bit, which is not too bad. Okay, goody. So then here we have the cuts. We go to model and combine and say U minus U, cut and keep the tool. Very good. Right click, repeat. The broom minus U, don't keep the tool, cut. So it's all nicely gone. Very good. Now we can work on the details, the filleting. So fillet and say you and you, baby, maybe 4. Yeah, 4 is fine. Very good. These details there are kind of sharp. So this and this is something that shows up in the rendering, a millimeter. Okay, looks good. Let's go to here, and this part is rounded. So we could go to Blender. I hide all this. Where is my scan? Dustpan, there it is. Because there I can clearly see how everything flows. So that whole thing, whoops, I select alone, export, wavefront, and I can call this one now OXO dustpan. It's all the same, very good. This might take a second. Okay, now insert mesh, dustpan, 20 megabytes, that looks correct. And see, it fits, snaps perfectly in place, very good. Now, this one we hide. I have to create now a sketch that helps me to trim down everything to the way how I need it. So new sketch to here. We will simplify this shape a little bit. So one line, let's say till there, and then a line till there. How is that? That's actually more arced. In our scan, that looks more like a line. So maybe let's say till there. Okay. And goody. Then go to sketch and fillet. You see this line and this line. I would like to fillet. Whoa. Fillet more. Okay, enter. There is that fillet. So it's radius, what about 250? 300? Yeah, okay. So that this fillet basically creates a nice transition between these two lines. We can also remove this fillet and we will simply do it a little bit different. So at this point, I move to somewhere else and then just move it maybe to here. Okay, at this point, I move a little bit to there. The main reason for that is now we will do this simply via fit point spline. So spline, click and drag, and then click, and then tangent to tangent, Very good. This M has to go a tick up, so we get a nice flow. Okay. And then here is the rest. S, fit point spline, click and drag. The click and drag actually, as you can see, if I now click and I click this, it creates a tangency constraint for me on the fly. Really nice. And then I move this one to where I need it to. Here, an M. There. Boom. Boom is actually what my baby now says a lot. Boom. It's really adorable. And uh-oh. And no, 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 no. There. This line is very close to there. So we move this a little bit up. That's good. You also can see because of the material thickness, purposely you will have some craziness happening there. That's fine. So we want to get rid of that stuff anyway. So this is all actually very nice. Very good. Stop sketch. Now this sketch we will use to chip off that stuff. Hold on, there's still something I need to double check. This actually looks more like an S. Right click, toggle curvature display, and there we can see it looks like an S. Yikes, so I have to fix this. Right click, curvature display. Okay. This basically says how and where the curve is being bent, meaning here it changes the direction. If I now click this point, press M, and move this one up and down, there we can see what's happening. Boom. There we are. That's good. Now this is a convex shape. Yeah. And it's all inside. Very good. And right click and say toggle curvature display to turn it off. That curvature display only works, by the way, on curves. It does not work on lines because lines don't bend. With that done, modify split body. You split by that sketch. Very good. And then this sliver left over we remove. Very nice. Take a look at that. Super duper. So let's do some double checks in terms of precision. Section analysis. Let's take a look at the section here. Perfect. Perfect. There's always a tiny gap. That's good. Let's do a plane here. Move this back. And I'm trying to pay attention to, does it get close anywhere? It gets actually closer here. So that's not super ideal. But hey, you guys do this stuff for the first time. If I would have spent a little bit more time, it would have been all very snug. But then again, this is a deformable material. Actually, the broom is wider than the opening for the handle. So you create actually a pressure snap. But for our purpose, this is super. Very good. Last thing, some fillets. Also for the handle. Oh, sorry, broom. You and you and you and you. One. Chord length is actually pretty good. As a 10.5. That makes it a little bit slower to calculate, but it gives the better fillet results I'm looking for. Very nice. And now I do one more fillet and actually round these edges. So that one and that one. Let's see if it works. 0.1. What about 2? Yeah, 2 works also. Very good. Good. In the real piece, this is actually very thin, so you can brush all the dust on it. For our exercise, I will skip this. So the last thing maybe to do is, how do we do these parts? See these small horns? And that's actually really easy. So first what I will do is I will show this, then I will make myself a sketch, very nice, and I will create a line, and I will do this P, project this point in. It's just this point you see there. Okay, because with that I can connect this line to this point and it's glued kind of like to that position. And when I now show the scan object, we're a little bit off. Nah, that's fine. So let's say somewhere there. Yeah, distance-wise, that looks good. Keep in mind, again, this is actually the scan of, we scaled this whole object, so this is not super correct. But with this still there, what we can do now is plane at an angle along actually the sketch, 0 degrees. Think about this kind of like as the ground plane the dustpan later would sit on. And we will create a new sketch on here, go to the top view, and then all we will do is maybe via the spline command, let's see, yeah, click, click, and click there. Maybe scale this out a little bit. Maybe a little bit to there, a little bit to there. I'm trying to even everything out. See, I'm just drawing lines, and via these lines, I create myself a nice regular structure there. Oh, let's offset this one, 1.5 millimeters. Yeah, okay, very good. And there, we close this. Very nice. No, this is not very nice. Because actually this is at an angle. I don't like, let's keep this. I would have done this a little bit different, but hey, let's keep this stuff manageable. Okay. Maybe we make this, we keep it this way. This I will set to horizontal, vertical. Actually, what happens if I select this and say B? Yeah, it doesn't do this. Okay, good. So this is one side. How do I get it to the other side? I will draw myself a line. Oh, there's already this line. Okay, very good. Or in case we do not see this, there we draw this line. Whoops. This line should be horizontal, vertical. We make this a construction line, and this now we will mirror over. So sketch, mirror. Select all this. So you, and you to there. Okay. There we have it. Cool. Okay, stop sketch. Then there's this. Now we can select the extrude command and blow it down. Oh, this is way too much. So I don't want to cut. I want this to join. And let me see. So you have to be careful how far you extrude it. We can sink it right into the surface. So that works pretty good. Control or Apple key, select this sketch. So we do both at the same time. Very nice. For the distance, we could also have set to object, and then I say here you and you. Select both surfaces, or it only goes one surface. Ah, sneaky. Okay, so what this means, it extrudes each surface and folds it right over that surface, so it does not intersect. And we would have to do this now on the other side. So I do another extrude and say distance to here, there. Very good. There we have our small stoppers. To make the whole thing maybe look a little bit more attractive, we can also change actually the rotations and say face, this face and this face, plus this face and this face. Rotate along this edge. Let's see, there we see we're just rotating this slightly out. Very cool. I mean, that's something you can do. You don't necessarily have to do it. But yeah, that makes the whole thing look a little bit nicer. A different way, so we don't have to do this rotation. And I will actually go back here to the sketch, and I'm just undoing all my steps till I have this. I'll show you something different. Because this is a repetitive element, we can just build it and then we mirror the 3D object over, just to show you a variation to it. So this we scale down. You see this ring. We can use this ring to also change the taper distance to here. Let's see, does it do it? Ah, interesting. It doesn't do it that way. So maybe in this case, we just have to do the distance by ourselves. So a little bit over, bring this in, and then let's hope that once it sinks in there, it does not penetrate it. Very good. So far, so good. A little bit wider maybe on the base. And there you see we're getting slightly through. So there. Pretty cool. So one operation. And then mirror feature. This feature, so that extrusion, I would like to mirror along this midplane. There we are. So I always do stuff double when we can cut the work by half and simply mirror stuff over. Okay, Nice. If we want, we can also here go to the fillet command and say you, and you. These are sharp corners, so we fillet those, maybe constant radius to 2, let's say 1.5, and then the fillet is you and you, and you, 1 millimeter, 0.5, 0.5, okay, and then we just make a transition for that. One actually still works. Okay, good. One, or here we could simply say 0.52, so a little bit softer. There we are. Okay, nice. That's everything for bringing the geometry over and bringing in all the fun details. In the last video, then I will show how we slice the surfaces, adjust the materials, and then we bring everything back over to Blender for rendering. Because if we want to do a real rendering, we need to have bristles. We can do bristles actually in literally the majority of CAD applications because they're not made for it. But bristles are a really nice element to have when you create this type of a product. And I will show you how we use the hair particle system instead of having nice braided hair like Frozen from Disney. We just do it for flat lines like Rumpelstiltskin or Struwwelpeter. Struwwelpeter is the guy with the scissor fingers, by the way.